Hi everyone. In these notes we're going to do some review over lines and linear models. So to get started, the first thing we want to remind ourselves is about slope. So if you have a line passing through two distinct points, you can calculate the slope by doing m, which is the symbol for slope, is y2 minus y1 over x2 minus x1. And what we're calculating there is we're calculating the rise, the change in the y direction, over the run, the change in the x direction. And something important to remember here is that it actually doesn't matter which way you subtract as long as you do it consistently. So I could do y1 minus y2 as long as I also do x1 minus x2. Okay, so we're going to calculate a few slopes to get started. So let's see, we've got line A first, this line right here, and we've got 2 points that it went through, given up here, and so we're going to go ahead and calculate the slope, and I'm just going to go ahead and do this y minus this one, so -7 minus -5, and so then I have to go in the same order, -1 minus 3. The most that you have to worry about on these is watching negative signs. So I've got a double negative here, which is going to change that into -7 plus 5. -7 plus 5 is -2. -1 minus 3 is -4. The slope here comes out as a positive 1/2. So it rises 1 and runs 2, and that looks consistent with the image. From one point to the next, it will rise 1, run 2, rise 1, run 2, etc. Okay, the next set of points is for line B. The slope here then is 2 minus -5 over -1 minus 3. The denominator is the same, -4, but the top turns into 2 plus 5. So we have a 7 over -4 slope, or -7/4. And that also looks correct. If we go from one point to the other, it would go down 1, 2, 3, 4, 5, 6, 7, and over 4. So that looks good. Now line C is this horizontal line right here. So let's check out how its slope works out. When we do this slope, we get -5 minus -5. Watch the negatives. And -1 minus 3. So again, the denominator is -4. The numerator turns into -5 plus 5. So we get 0 over -4, which is just 0. So what happens here is that the slope, remember the top is rise, so it rises 0 as it runs. So there's no vertical direction at all, no vertical movement on that one, only horizontal. So that kind of makes sense. And let's change colors again so that we can see this vertical line, line D here. The 2 points we've got are right there. So let's check out how that works. When we find the slope of this vertical line, we get -7 minus -5 over 3 minus 3. So we get -7 plus 5 over 0, or -2 over 0. And when we have a 0 in the denominator, we have undefined. So there is a very, very big difference between a 0 slope and an undefined slope, and they are not interchangeable. Undefined is for a vertical line, when there is no run, when there's no movement in the x direction. 0 is for a horizontal line when there is no movement in the y direction. So to kind of summarize all of that, and let's remind ourselves, if a line is rising to the right, so if it is going up to the right, the slope is positive. It will have the form y equals mx plus b, where m is a positive value. If the line is falling to the right, its slope is negative, and it has the form y equals mx plus b, where m is a negative number, negative slope. If a line is horizontal, so I'm going to go back to that orange since that was this one right here. If a line is horizontal, the slope is 0. The equation form for a horizontal line is y equals b. Because the m value is 0, so right, that comes from y equals 0x plus b, which just turns into y equals b. So that's where that comes from. If a line is vertical, its slope is undefined, and it has a completely different equation form. Because there is no movement at all in the x direction, it's all just the x value here is the only one that's locked in. Notice this particular line here was at the x value of 3, and every single point on this line has an x value of 3. So that becomes the equation. It's just x equals whatever x value happens to be there. So those are the two kind of specific ones that we want to make sure that we keep straight, is the difference between undefined slope and vertical lines and 0 slope and horizontal lines. Those are easily confused. So that's something we want to watch for as we move on. We are usually given information about the line, and no matter where we start, we want to be able to write the full equation of the line. So there's lots of different ways to get information to start, but we always want to end up in this slope-intercept form, this y equals mx plus b form, unless you're specifically told otherwise. So you may use these other forms to get started and to get there, but that's where we always want to end up. So when you're in that form, you have given to you the slope m and the y-intercept 0, b. Now that's not always given to us. That specific information isn't. They could start you with just the slope and a point, and there's a way to get started there with this point slope form, but then you can multiply through and distribute and move everything around and eventually get back to y equals mx plus b format. Same thing with the general form. They may give you the information to get started there, but we would want to move that around likely to get it into slope-intercept form. And then again, horizontal and vertical have their own special formats. So on this one, on this first example, they give us 2 points. That's where they're starting. So we don't have a 2-point form. There's no form for that. But what we can do when they give us 2 points is let's first find the slope. That's definitely something we're capable of finding given 2 points. So if I find the slope here, I'm doing -1 minus 5 over -2 minus -4. It's -6 over -2 plus 4. So -6 over 2. So slope of -3. Now I do have slope and I also have points. So I could use this form right here, the point slope form. So that's the first one I'm going to use. I'm going to do it 2 different ways to show you that there are multiple ways to get where we want to go. So the first way we're going to do this is we're going to use this formula. We now know that the slope is -3. And what we have to do is pick a point, pick one of these points, either point 1 or point 2 up here, to put in as our x1 and our y1. You can do it either way you want. I usually prefer, if I can avoid any negatives at all, I try to do that. So I'm going to pick this point just because it has one less negative to worry about. The x value there is -4, so I put that in, and the y value is 5, so I put that in. Again, I would not ever want to stop here. I would want to distribute. This turns into a plus. And then when I distribute, that would be -3 times +4, so -12. And then I would add the 5, and I would end up with y equals -3x minus 7. as my final equation there. There are other ways to get here. The other way that most people like to do it, it's usually one of these two ways right here, is to go ahead and just go straight for that slope-intercept form. Say, this is my goal. I want to end up with something that looks like this. I know M, so I automatically know it already looks like this. But I'm looking for B. This is what I don't know. I can sub in any x and y value and find B. So I'm just going to use that same x and y value here. The y value of 5 and the x value of -4. I get 5 equals 12 plus b. Solving for b, I get -7 is b. This one's great. It seems like it's a little bit easier for students, but what I do see, the downfall of it, is that students will stop here. We're not done. The question was, what's the equation? So then I have to go back and say, oh, I found my b value, which means my equation is y equals -3x minus 7. You have to do that extra step. You have to remember that. So I don't care which way you do these. Those are just both ways that are fairly easy and accessible to get the job done, to get the full equation written in that slope-intercept form in the end.